about the technology of how we can bring together automation and agriculture in the reality of what is now, instead of actually waiting for the future. So continuing on through my presentation, current ag aims at the moment is that we've got this Mauthausen catastrophe to actually try and feed the population that is ever growing. We need to actually grow more food, and we need to actually do it correctly, and we need to kind of make sure that this variation that we're getting within our ground is actually dealt with correctly. So how do we increase sustainability, and do we actually get more precision within farming? There's ideas of the 4 rights and everything else, just trying to get everything working correctly within our agricultural society. How can we do that? At the moment, we've got really big machines working within agricultural environments, but it hadn't necessarily been that way. The entire idea of us starting with horses and carts to actually try and get our produce out of the field using small single furrow plows then came up into the Industrial Revolution, where we had very heavy machines, and we learned quite quickly that we couldn't put those in the fields because they'd get bogged down. And then we kind of came to this point of the old grey Fergie, the old T20, where everything was kind of coming together correctly, but you needed one person per one fairly small machine. And because we've kind of got this one-upmanship with ever larger machines, more power will solve the problem, we're going to actually get to these larger and larger machines, but we're getting to the point, especially kind of today, where you can get in the field, but you'll start damaging that soil that is ever so precious to us. So we kind of took a step backward to make sure we understood, well, what the agricultural automation system would be, and that would be a smaller machine. Okay, let's keep on clicking the buttons. This is the area that we developed the hands-free farm. So a fully autonomous cereal farm with multiple vehicles and fields with swarms of precision machines working in the field and the farmyard. And the idea of all of this was to actually go down into a smaller agricultural design where we could bring these machines to work together in cooperation, where you would originally have a single farmer sat on the seat of a tractor, but now these have become automated machines that are driving around with control, and we're precisely sending them exactly where you want them to go. And this is really exciting. So we've brought together Precision Decisions, Harper Adams and FarmScan to take the step up from originally what was the hands-free hectare, where we were the world's first to grow a crop in the field without ever going into it, and just take it that next step further. What is the hands-free farm and how big is it? So it's 35 hectares, a big step up from the original hands-free hectare, as you can see in the corner there. And what we've done is made this more complicated to understand the traditional farming topography in the UK. We've got wiggle the edges around our fields. We've got traditional challenges where you've got waterways running around the side, we've got telegraph poles, we've got walking ways, we've got public rights of way all the way around our farm. Because we're Harper Adams Farm, we have to take into all the realistic aspects that you would be having, instead of in a perfect ring-fenced rectangle that we started off within the hectare. So we've got multiple different fields, and we're growing them in their traditional methods of agriculture, where we've got the 3 separate year projects. So what we were trying to do was grow 4 separate types of crop. We've got some barley, we've got oats, we've got wheat, and we've also got beans. And we're trying to grow those all of the 3-year rotation within our 3 years of the project. So starting in 2019, and we didn't have a great year for harvest and growing things because of the weather, but we've still managed to do a certain number of applications that will continue on into this demonstration and conversation we're having today. We're trying to work from going from 1 to 2 autonomous tractors and 1 combine to up to 3 tractors and maybe 2 combines if we continue the demonstration of how well these machines can work together. And the whole point is to actually be the world's first farm that is utilizing autonomous machines to try and grow a full harvest. It's not necessarily about keeping everything off, and The whole point is to actually allow the people who would originally be driving the machines to start doing the additional agronomy and allow them to make the better decisions on how you would run this particular farm. We've managed to drill, we've managed to spray, we've managed to roll, and we've managed to do a number of autonomous actions so far within this challenging year, especially within COVID. And now we're starting to actually get into the next point where we're working towards planting all of our winter crops and get everything underway. And we're continuing in that very much vein. From this point on, I believe I'm going to pass you on to the next talker, which will be Clive. Clive, are you there, my friend?
Sorry, yeah, the wonderful mute. If you just move us on to the next slide, please, Jonathan.
Again.
My name's Clive Blacker. I'm from Map of Ag. I'm also the Director at Precision Decisions, and we were one of the founding partners with Harper Adams to actually study and understand what influence we could have on farming going forward with robotics, with the hands-free hectare. And from a Map of Ag perspective, you know, the concept of being able to operate and manage data around farms is becoming really a challenge. We're all about trying to connect, inform, and transform our data, and we saw that the hands-free farm has been a fantastic opportunity to further the learnings that we'd had from the hands-free hectare, to try and support the farming systems of the future. You know, the challenges that we've talked about today already, that you heard Tom Bradshaw talking about with compatibility and frustrations of getting data in and out of platforms, and the ability to grasp and analyze that data. They're all certainly challenges that we resonate with. And we saw these projects as being an absolute fundamental key to being able to get first-hand experience of how we can really understand that data challenge. And understand what can do with data in the future, and the new techniques and technologies that we're going to need to develop to be able to connect, inform, and transform that data into a position not just farmers can use, but equally that also robotics potentially can use in the future. If you go to the next slide, please, John. And part of what we're achieving within this development project is very much supporting the robotic operation in field. The role of Precision Decisions is to supply some of the engineering support, but the practical understanding that we have of software and agriculture combined. And what this is allowing us to do is to create a platform that's going to allow us in the future to support standard farmers, no matter what size, to get better insights of data and information, to make that data and information more available and unlocked to them, and to combine the disparate sources of different data systems and technologies that are out there, so that we can actually make, as farmers, joined up decisions. But equally, we want to take that, rather than just being a predictive system, to actually be a prescriptive system as well with the robotics. And for us to really understand what we're doing, having full links with telemetry to tractors, to be able to monitor what we're using from a fuel perspective, from a safety perspective, and from an operation perspective, not only allows us to get better costings and insights on how we can develop and grow crops in the future, but equally to support greenhouse gases and really understand our climate obligations and liabilities while we're producing crops in the future. And certainly one of the exciting things about the project is the ability to work with the science. If you go to the next slide, please, John. So one of the benefits that we actually have from this project is being able to actually link with within the university at Harper Adams and the science departments we've got there, working at novel understandings and treatments on how we can potentially utilize the staff and the capabilities of students there. Being able to monitor fields, for example, to be able to do full research projects, so we can actually put numbers and figures to the data that we're collecting and the operations that we're running on the farm. And we think this is really important. It's absolutely fundamental that the opportunity that we have with Harper Adams and with the Agri-EPI Centre here, that we can actually challenge the next generation of agricultural technologists that are going to come through from Harper Adams to actually think about the future as well. And it's been a great opportunity to challenge thinking about what new hitch systems might look in the future to allow a automated tractor, for example, to take an implement on and off unaided. How we can undertake some of the challenges we've got in respect to filling the drill and making that an autonomous process, and really being able to drive the efficiency that we're going to need from systems in the future to remain competitive. At that point, I'd like to hand over to Callum, and Callum will tell you about some of the great stuff that we're integrating our data platform with on how that operates and aligns with the operation.
Thanks for that, Clive. As Clive said, I'm Callum Chalmers. I'm the UK Director for FarmScanAg. We're very happy to be a part of the project, and our main role is we were brought on as the technology partner. And our goal is to basically make sure that when these vehicles are in the field, that they operate as commercially viable as possible. So that's bringing all the precision agriculture aspects that we would use in our day-to-day business and turning those into autonomous systems that we can deploy onto these vehicles and have them operate in the field. So John, if we can jump forward. So most recently, we've completed some cropping in Nearmore, which was the 12.6 hectare field, I believe. We planted some winter wheat about 2 weeks ago. Interesting fact is, due to the weather and the constraints we've had, this was the first time we've actually drilled a true crop. We've done some cover crops, but this is our first crop. Then we came across several challenges that an autonomous system would definitely introduce. And one of those main ones is making sure that when we're in the field, we are exactly where we need to be. And so one of our goals is to have RTK steering throughout the whole system so we can position ourselves accurately. There's two parts in that when we go to autonomous systems, which is straight lines and curves. In normal RTK, in precision ag, we have standard straight line steering, which is a common aspect that most people would know. And we've moved on to automating the full process, which means turning around at the ends and sort of navigating difficult headlands, which might not be straight, and making that all successful. In this project, we're trying not to shy away from things that would be challenging. We're trying to make sure that this is a commercial product, and the concept is that fields aren't round, fields aren't square, so we need to be able to, if we can, drill around headlands or lift and lower at the appropriate times. I think overall it was extremely successful. I think our coverage was good. We learned a lot from it, and we're looking forward to drilling some more as we move forwards. Thanks, John. Can we step forward? So one of the important things we learn when we are drilling and when we are using these systems is that precision is a really key point, and it needs to be one of the most vital things that we handle. On the left there, you can see a coverage map that we completed using a low-cost free-to-air GPS that had EGNOS. So that's sort of 1 to 2 meter accuracy normally. And then on the right, you can see the same field, but that was drilled with an RTK GPS. And you can see that the variability that we have is just massive when we don't use the right tools and we don't have that RTK precision. On the right-hand side, you see some missed parts. It's a key thing for us to know either machine faults or where there are gaps, so that if we need to, we can fill them out. And if you don't have that increased precision, then it's not something that we can facilitate later on. And using the precision and that aspect of it, we can start to really utilize the smaller machinery. When we're going down to these, 1.87 meters is the drill width, we can look at having variable rate maps that are much more accurate, much more dense, have variability to try and decrease the variability across the field by varying the rate. We can also, if we get down narrow enough, we can look at potentially having 2 crops in the same field, and really utilizing the fact that we are using smaller machines and just more of them. And that brings me on to some of the challenges that we have while we're steering. So it has been definitely challenging. We're moving from the hectare, which was nice, square and flat. We've moved into some fields which are had a fair bit of work done to them, but they're still quite bumpy, and using smaller machines is definitely something that we notice. We are retrofitting machines as well, so we're effectively using machines that are maybe designed for slightly smaller, and we're using them in an unconventional way, so we can expect some unconventional results. Effectively, we have sensors that we need to use, and the more things that impact that, we've got GPS and then also the wheel angle sensor, and all of that, the precision of that really impacts what we see on the ground. We've been doing quite well so far in terms of coverage. I don't think we've missed any big spots, but all of those systems need to work together harmoniously for the system to work completely correctly. You can see a small video of the sprayer there. It's quite heavy, and that does lead to some interesting in-field dynamics with sway. And in terms of steering, it's very challenging to keep that straight and keep the coverage accurate when we're doing that. And we'll move on to combining. We have a class Crop Tiger combine that we're modifying to be completely autonomous. That couldn't be possible without some partners that we've used, which are Linac and Eaton, who are helping with some of the necessary requirements to retrofit this to be a system that we can actually use in the field completely autonomously. Right now, it's all manual switches, and we need to improve that to be electronic systems that we can use. When we move to something like a combine, safety starts to become a key problem that we are going to run across a lot of problems with, but we've got the right sensors and the right systems in place for safety, including remote stops and using multiple LiDARs and a computer vision system to effectively really understand what's happening around the machine at all times, and so that the machine, if necessary, can stop in an unsafe situation when we've got something like a cutter bar operating. That's the combine. Thanks, John. One thing that we're looking at as well is ISOBUS. It's a system that's being used more and more throughout the world with the goal of improving compatibility between systems. At this stage, we've been having some challenges with it, but we're committed to proving that this systems work and that we can have these multiple ISOBUS systems working autonomously. So we're working with some partners like Amazon and Topcon to try and integrate their various systems and sensors. And the real goal is to use modern systems that everyone would have, that everyone's seen every day, and prove that these systems can work in an autonomous fashion and not have something that's completely ambiguous and completely incompatible with what's existing in the modern market. And that covers ISOBUS, leading into something that we've been working on as well, is the swarm automation. We've got some very large fields and we've got some reasonably small machinery, which means that we need to be smart about the way that we break up the work that we have to do and ensure that when we're in the field, we're doing the right sections at the right time and we're not cutting any corners. The class combine can't get across the whole field without getting full. So we've got to be more creative in terms of the way that we handle this and what we do to effectively combine the whole field. We're looking at this stage at unloading on the move and really driving the efficiency up of our combining to be more commercial. And it's all about the synchronization of multiple systems working in the field. So we have multiple tractors with trailers and a combine. That's our end goal. We're taking it at stages so far based on safety and making sure that we can maintain safety while improving functionality, and with the end goal to be sort of unloading multiple vehicles in the same field at once. But hopefully we'll have a trial of this next year to harvest our winter wheat once it's all nice and grown. And I think that covers me, John. I think you're muted, Matt.
Excellent. I clicked it twice. Okay, so yeah, just to kind of discuss what we've done so far with our autonomous cropping and planning and how we were able to work together with our systems. We've worked on, these are the 5 fields that you've kind of seen in the pictures above. We've drilled cover crops autonomously, and we've run through flailing systems autonomously. Oh, there we go. It's pressing the space bar. We've managed to run through drilling and making sure the systems are working correctly. So just when we were able to actually get out of lockdown, we did our first area of cover crop planting. as you can see, it's a very small tractor and a big field working together quite nicely. And these were areas that we were allowed to do a lot of learning on our straight lines and curve turns. And then we've run through as well to kind of run with flailing operations, which slightly narrower width than our drill, but allowed us to understand exactly where the vehicle needs to be with its implement in the set part of the field to do an operation correctly. Continuing on into the next part of how we're working together with smart technologies. As you might be able to tell, I would always try and add drones into any particular situation and get it to work correctly. So therefore, we've been using aerial sensing to allow us to reduce the amount of chemicals that we want to spray over our cover crop. Therefore, this is a kind of demonstration of how we were working together to have adjustable variable rate plans for not just the near moor, but the middle moor fields, to understand exactly how we're going to change up our spraying techniques within there to allow us to reduce the chemical usage and become ever more efficient using our autonomous machines. Continuing on to that, we're just actually showing how we're spraying off with herbicides, some autonomously, some not so at the moment, mainly due to us allowing to get ready for certain operations. At the moment, we're very, very challenged because we've got some of our fields which are quite waterlogged, which is definitely causing us some challenges and some sleepless nights. But we're working together with the autonomous spraying and everything working together on that one. And on Monday last week, we had Princess Anne come round to see the hands-free farm and understand exactly what we were doing to have our winter wheat crop being planted autonomously. So we've managed to do many operations such as rolling to spraying, which we've done fully autonomously, to then start working. And then it comes down to a quick chat about the combine harvester. Despite that not running in a full autonomous mode, what we've managed to do is change almost every single operation except for the tank track control into fully electric actuation. So all the levers and hydraulic rams that were fitted to the system have now been changed to button switches, meaning it's kind of fly-by-wire, allowing us to get to the next stage of running it autonomously. So we're really, really in a good stead to allow us to continue on with this project. Just one last thing about the implication and the economics. So far, we've managed to publish a paper with two of our economic professors at the university from the information we gathered from the hands-free hectare, where we get some really good understanding on the kind of fuel economies that we're getting from small tractors to medium and large size tractors working with the UK sized fields. What we're trying to do now is kind of understand exactly how we can work this. And with some partners that we've got with Chemo, we've been able to understand how much fuel each operation is taking and allow us to actually understand how much fuel per hectare, a really nice metric that Clive keeps on bringing to us to make sure that we understand exactly how efficient we're being within the in-field operations. And that's where we're going into this entire project. And it's just taking some time for us to start drilling all our crop, and from there, hopefully over the winter, we'll start analysing all that information that we've been gathering from running our vehicles for long hours in the fields. And from that, that is the end of my presentation. I really thank everybody for paying attention to myself, Clive and Callum. And I suppose this is the time we open up for questions, or it's Duncan, I guess.
It's going to be question time for you guys first, just for the next 5 minutes, if that's okay. Kept perfectly to time there. Thank you for your presentation. We have 2 or 3 questions that have come through from the audience. So the first one is from Charles Nicklin, and he asks, what is the main reason for trying to go for smaller machines? All the major OEMs are driving product development teams to go larger and increase productivity. This will be especially important in large acreage farms, where vast areas need to be covered as fast as possible. So the question there is, what's the main reason for trying to go for smaller machines?
Okay, guys, if you don't mind, I'll answer this question. Yeah, so it's all about small machines actually having a more precise application onto the field. and having less damage on the ground. So it's about having less compaction and less damage to the main area of the ground from being a smaller, precise machine. And the other aspect from that is that because we're not having to scale up to allow a single operator to control this large machine with a wider implement, the idea is that the smaller, cheaper machine can be scaled up in numbers and run together in fleets, which allows an entire operation that would be generally scaled up in size to just have multiple machines working together, allowing us to have less damage to the ground and more precise application and control on our field sizes. And this is what we've really worked together to understand that is quite important with kind of the UK agricultural sized fields, where we've got hedges, water courses, and actually quite small fields in relation to other areas around the world. But scaling up in multiple machines and having more precise application capability allows us to have a completely different niche. The other aspect is that we haven't spent out millions of pounds developing an ever bigger machine. And now that with investors actually working on those larger machines, we're expecting to have some comeback from all that money. Well, we're going down to the other point of making sure the machines that have been designed just like the old T20, which could work very well within the field and not damage the field, will actually still continue to work from its new modern counterparts, for example, from Imagery.
Okay, and Jonathan, do you think that farmers are going to be able to afford a fleet, or is that where collaboration comes in?
We believe from the first cost of the hands-free hectare, we were able to show that we could develop a full autonomous vehicle for under £30,000. And that was just completely with the technology that was off the shelf from eBay and Amazon. And what we really want to start doing is actually showing that these smaller, cheaper machines don't necessarily have to have the crazy technology that some of these ever larger machines have. And you can start reducing some of the additional costs, such as aircon and cabs, onto the vehicle, allowing you to have an even lighter machine.
Okie dokie. We've got another couple of questions.
Sorry, Callum,
go on.
A big
part of the project that is also to evaluate the costs and the feasibility of this. You know, it's really important that we try and understand from a business perspective where this all stacks up. And we could end up with a lot of egg on our face with this, but you don't know until you try. And certainly as we think longer term about where agriculture may go in the UK particularly, if we're going to be looking at natural capital and rewilding areas and having smaller parts of fields, then there's going to be chances that smaller machines are going to be better required and better suited for some of that. And there was an aspect that Callum mentioned as well in respect to cropping. I think one of the big limitations that we face in the industry today, Tom Bradshaw alluded to it, was the precision. And it's about precision and attention to detail. And the way we crop things today and the way we manage our fields today is all limited by our engineering capability. And just because we're bigger and we have precision doesn't mean to say we're more precise, as daft as that may sound. And I do think there's a huge opportunity to really look at where we can take cropping in the future in high resolution to grow multiple crops together and get synergies and different opportunities and ecosystems going.
Yeah, no, not the answer at all, Clive. Thank you for your responses there. I think we've got time for one more question, and that is from Helen Glass. She asks, do you envisage a role for machinery rings and autonomous machines? What will the service and training packages look like?
There's lots of different concepts for the future of where robotics may go, and it may be service provision. So you might, for example, in the future, buy your seed from a wonderful seed supplier like KWS, who support us with an automated solution, and they will understand how to plant it best, when to plant it best, and they supply you the technology to do that. There's lots of different business models there. I don't know whether any of the other guys have thoughts on that.
Yeah, I suppose my application and understanding, as I always bring into drones, and I keep on people chuckling in the background, is that Chinese systems such as DJI and ZAG have been working together with spray systems for a good old time, and they run as a farm system pack where farmers don't operate or use any spray systems of their own. They call in the contractors just as you would with an Uber system, where you mark out the area of the field that you want to have treated and you request that area to be sprayed. Then fleets of systems come along with a number of operators from 1 to 3, where up to 10 drone systems will be flown over the entire area and spray completely autonomously. And in the demonstration of how our smaller ground race vehicles would work, we envisage that same system to keep on working out in the same sort of concept.
Brilliant, thank you very much. A big thank you to the whole hands-free